Section 7.1, integration by parts. So what is integration by parts? So if we try to integrate something like this, x to ex squared dx, then people say, okay, I can use u sub. So on the side, I take u to be x squared, du is 2x dx. And then you can come back to this and say, okay, I can, all I have to do is multiply this by 2 because I need the 2 in there and 1/2 outside. So then this becomes 1/2 e to the u and the rest is du. So 1/2 e to the u plus c. 1/2 e to the x squared plus c. So that would be fine. But if I take the same problem and we say, hey, integrate that problem, the x e to the x squared, just change it to x there, then that's not easy to do. If you try u sub, it's not going to work. Okay, it's not going to work here. What are we going to do in this case? Think about it in a different way. Okay, think about it in a different way. What could be the other way? Well, everything we've done so far is not going to work out. Everything. So what do we do in this case? We need a new tool. We need a new tool for that. And what's the new tool in this case? Well, we look at f of x times g of x. If I have two functions and I want to find their derivative, the derivative of this by the product rule is f prime of x times g of x plus f of x times g prime of x. That's the product rule. Right? So that's what we covered in Calc 1, product rule. And what we are going to do here from the product rule, we are going to rearrange this equation that we just got. I'm going to solve for f of x times g prime of x by subtracting, keep f of x times g of x derivative as is, and subtract f prime of x g of x on both sides. Then we're going to integrate all of this. So the integral of f of x g prime of x dx is the integral of f of x times g of x derivative dx minus the integral of f prime of x g of x dx. The one on the left side, nothing can be done for that. Just keep it as is for now. On the right side, the integral will cancel the derivative. So that will give me f of x, g of x, minus, usually we put the g of x first. We can rearrange it, f prime of x dx. Now to make this equation simpler to memorize, if we let f of x be u and g of x be v, then that equation that I just proved becomes f of x is u and g prime of x dx, that's dv, equals f of x is u, g of x is v, minus the integral of v du. That's the integration by parts formula. With the nice frame, because it's important formula. So if we go back to this problem, now to integrate this, because the u sub didn't work out, we're gonna try using a different method, maybe the integration by parts. But before we do this, notice how the integration by parts is. Part of it has to be u and part has to be dv within that integral. So how do I know which one is u? Of course, all this will come with practice, but we have a little trick we can share with you that would help you down the road, that, oh, maybe this helps. It works, I would say, 95% of the time. And the trick said, I like this, I and late, L-A-T-E. Like, but I doesn't start first, like L starts first. I late. So L for logs, I for inverse, A for algebra, T for trig, E for exponential. And again, we need part of this integral has to be u, and the rest is dv, right? U and dv, u and dv. So which one is u? Well, you look at this. What kind of functions we have? We have algebra, we have exponential, algebraic and exponential functions. Which one do you come across? Which one do you come across while you're going from left to right? So if I'm traveling this way in this trick, do I come across exponential first or algebra? Well, I come across the algebra first. So the one you come across is going to be our u, which is x. Everything left, ex dx, that's our dv. So from here, we always find du. Du is 1 dx. And here, to find v, you kind of integrate both sides. So the integral of dv is v. The integral of ex dx is ex, going backwards. Why did we do this? Because that integral I'm finding now, I'm going to use the formula. If you go back to this boxed formula here, it says uv minus integral v du. So uv minus integral v du. U is x, v is ex, minus integral v again ex, du is dx. And let's see what we get. This stays the same. Integral of ex, plus the constant, not to forget the c. So another example, integrate natural log of x dx. Again, in all of the respect, we always try to start using the u sub. If u doesn't work, you want to try integration by parts. So for example, in the by parts we have to do u equals something, and whatever left is dv. dv equals something something. So what is u here? What is u? Well, if I look at this, there's only ln. There's nothing else to take. So I'm going to take u to be ln of x. And what is left is going to be dv, which is dx. So now try to find what du and what v are. From du, we get the derivative of this 1 over x dx. And v, the integral of dx, is x. So now the formula said uv minus the integral of v du from the formula for the integration by parts. Always write down the formula, this way you get to memorize it. This stays the same, minus these cancel dx. This stays the same. Integral of dx is x, and don't forget the plus c. I took the first example that we did, but now I change x into x squared. Here we have algebra and exponential. So we always take the algebra first before the exponential to be our u, and whatever is left, the dv is ex dx. So when I differentiate this, you get du is 2x dx, and when I find the v, the integral of that is ex. So this tells me this one here I'm looking for, it's uv, so it's x squared ex, minus the integral of v du, like that. Of course, we can take the 2 out, so keep the left hand side the same. Take the 2 out, x ex dx, and now, oh, that doesn't have like an, it's not just ex dx or x dx to integrate. We have to work on this by itself. So on the side, you're going to do this again, integration by parts. But if you like, remember we did the same problem earlier. That was the problem we did. Do you see the example, the answer? We can copy that answer here. If you like to do it again, you're welcome to do so. But I don't have to because I just did that. So that was x ex minus, what was it? X ex and ex. Ex. You can put the c out. So this stays the same, minus 2x ex plus 2ex, if you multiply it out, plus c. So that would be the answer to that problem. We can look at another example. How about ex cosine x dx? So I can write LIATE. I have exponential, as you can see, this, and trig, this. So trig comes first, so that's going to be my u. U is going to be cosine x, and whatever is left is dv, which is ex dx. Now, from here, du, what's du? Negative sine x dx. From here, I'm going to integrate, gives me ex. So then, the integral ex cosine x dx we are trying to find is the uv, so ex cosine x minus the integral of v du, ex negative sine x, which will make the outer plus. Now again, we came across another one, this one, that we need to integrate by parts as well. Okay, so how do you integrate by parts? You take the u to be sine x, because the u is trig, and whatever is left, the dv, is ex dx. So from here, I can find what du is. Cosine x dx. And v is simply ex. Then I apply the formula here, uv minus the integral of v du. U is sine x, v is ex, minus u is sine, and dv, uv minus the integral of, oh sorry, the integral of v du, v is ex, du is cosine x dx. So I'm going to take all of this and substitute it in there. Let's see what we get. Keep the left hand side the same. Equals ex cosine x plus what I just got, sine x ex, minus the integral of ex cosine x dx. And now you're going to say, oh my god, I see this again. What am I going to do? Do it again? The answer is no. Why? Because this is exactly this. So what I can do, I can add that to both sides to get two copies of e to the x cosine x dx equals ex cosine x plus sine x ex, or ex sine x. And then I'm solving for that one. You can put plus c. I'm solving for that integral, so I'm going to divide everything by 2. So the integral I'm looking for now equals 1/2 ex cosine x plus 1/2 ex sine x plus c over 2 or c, it doesn't really matter, just as long as they're constant. So this is one of the examples where it start looping, start going around, and then if you do not recognize that, hey, I need to stop here, I need to do it, this is my, that's where I need to stop because these look the same, and solve for it, then it's gonna keep going on and on and on, and it will never end. And after we are done with that one, we have to integrate sine x natural log of cosine x dx. So our u is gonna be, our u is natural log of cosine x, and dv is the sine x dx because the log comes before trig. So du, the derivative of this is the derivative of that, negative sine x over itself. Don't forget dx. And v here, the integral of sine is negative cosine. If you like, you can rewrite this as negative tangent x dx and keep v the same. So then that problem becomes uv, if you like to write the formula down, minus the integral of v du. U is natural log of cosine x, v is negative cosine x, so I can put it there, minus v again negative, that makes it positive, and du is negative sine x over cosine x dx, so these cancel each other. Then this stays the same, this stays the same, minus the integral of sine is negative cosine, so that makes it positive, and don't forget the plus c as always. This one, let me make it definite integral, arc sine x from 0 to 1. First, note it's a definite integral. So different people might approach it differently. You know, some people, when they use the u, they change the bounds from x to u for the definite bounds 0 and 1. I don't do that. I just go with, assume it's indefinite, like that. I do the work on the right side. The only function I have that can take u is the arc sine. Arc sine is the same as sine inverse. And whatever is left, the dv, which is dx. So what's the derivative of arc sine? Is the derivative of x over the square root of 1 minus x squared. Don't forget the dx. And from here, v is x. So then, the way this works, it's uv minus the integral of v du. U is this vx, so x arc sine of x minus the integral of v du, it's 1 over that. Now to solve the problem down there, that integral, it doesn't have to be always by parts. We always look as the first step as by substitution if possible. Like we can integrate this on its own by taking probably u to be 1 minus x squared. And du would be negative 2x dx. So if I want to do that on the side, On the top I need a negative 2, multiply the bottom, keep it the same, negative 1/2. Negative 1/2, the top du over the square root of u. 1/2 u to the negative 1/2 du. And then negative 1/2 u to the 1/2 over 1/2. These cancel. Negative square root of u. So that would be negative, negative, positive square root of u, which is 1 minus x squared. So that goes up there. Now I have that integral that I was trying to find, 0 to 1 arc sine of x dx. It's giving me x arc sine of x plus the square root of 1 minus x squared from 0 to 1. Now we can, that's from x equals 0 to x equals 1. Now we can finish by substituting the 1 first minus the 0 next. 1 arc sine 1 plus 0, 0 plus the square root of 1. Arc sine 1 is pi over 2 minus 1.